Okay, so question number 6. What is the hybridization of the carbon atom in CH4? Okay, so to answer this question, we would need to write out the Lewis structure for CH4, which is methane. So first we need to calculate the total number of valence electrons in this molecule. So carbon has 4 valence electrons, hydrogen has 1, and we have 4 hydrogen atoms. So we multiply this by 4 to give us 8 valence electrons. So now if we drew out a skeletal structure with carbon as our central atom, we can draw the 4 bonds to hydrogen. And if we recall that each bond contains 2 bonding atoms, then you can see that we already have our 8 electrons in this structure. So this is the final Lewis structure of methane. So now we need to find out carbon's hybridization. So there are 2 ways that we can do so. So the first is by using the Vesper theory, which we can then use a Vesper theory chart that summarizes the hybridization and the molecular shape and electron geometry. So if we analyze the carbon, there are 0 lone pairs and 4 bonded atoms. So now, using a Vesper theory table, we can find out its hybridization. So when you have 0 lone pairs and 4 bonded atoms, you have an sp3 hybridization. So this is one method, which is using Vesper chart. But let's say we aren't given a Vesper chart like during a quiz or something, so we just need to find its hybridization. Another method we can do is by counting the number of charge clouds. So charge clouds are both the lone pairs plus any bonded atoms or bond pairs. So for example, when we have one charge cloud, well, let's start from 2 charge clouds. Then our atom is sp hybridized. When we have 3 charge clouds, we have sp2 hybridization. And we have 4 charge clouds, like in our example, then it's sp3. And 5 charge clouds, sp3d. And we can have even 6 charge clouds, sp3d2. So you can see in the Vesper table as well This is related to like total domains on the very first column. So 2 domains is SP, 3 SP2, 4 SP3, 5 SP3D, and 6 SP3D2. Okay, so that's another method that's pretty easy. And let's see what the junior tutor said. Hybridization is the concept of the fusion of atomic orbitals in order to form newly hybridized orbitals. These newly formed orbitals influence molecular geometry and bonding properties. Hybridization is also an expansion of the valence bond theory and helps explain the bonds formed, the length of bonds, and the bond energies. The hybrid orbitals used depends on how many electron groups are around the atom in a particular question. An electron group can either be a lone pair or a bonded atom. Okay, so they have their examples. SP is when you can have a triple bond and the carbon only has 2 bonded groups. SP2, there's a double bond and there's 3 charge clouds. SP3, all single bonds. Okay, so this solution is correct.